For this session, it's my pleasure to introduce our very special guest speaker, Ryan McMeniman, the Global Director for Product Management in the Open Telecom Ecosystem and Partner Certification Lab from Dell Technologies. Welcome, Ryan. Thank you very much. Please give him a big hand, ladies and gents.
Thank you very much. Appreciate it. Looking forward to talking to you all today. Always available after with questions that we're going to go through things. We'll try not to do a heavy Dell pitch, but I will answer why Dell and Telecom as we're going through this, because we get that quite a bit. So as I mentioned, my name is Ryan McMeniman, Global Director of Product Management for the Open Telecom Ecosystem Lab. What that is, and we'll go into that in a little bit, but my other speaker, do you want to introduce yourself?
Yes, thanks, Ryan. Mehran Hadipour, Business Development and Partnership for Rakuten Cloud division of Rakuten.
Excellent, thank you. So what we're going to be talking about is why Dell brought Rakuten into the Open Telecom ecosystem. What was the impetus for that? And it really is going to start, we'll go through a few slides, is what is the shift that we're seeing in the marketplace? That shift from that traditional silo to more cloud-native approaches. And the idea is achieving that performance parity with those traditional siloed systems. What we're going to be doing is, in going through, is why vendor validation. Vendor validation is something we're seeing required in every RFP, RFI, as well as the roadmaps from network equipment providers and other small ISVs that are in the space that want to understand how can they operate in this cloud-based environment. And lastly, it's proving that out. What we see time and time again is customers want to know what is that golden configuration, what is that blueprint that they know when they take a disaggregated network vendor selection, how is that going to work? What does the lifecycle manage look like that? So that's a key point. So when we talk about this, no matter where you are in the network, traditionally, you would have had one stack for your IMS, one stack for your RAN, one stack for your core. But more and more, when we move from physical network functions, which I think many of us are familiar with, the idea of having it from a single vendor, is that next phase. And so if you go back to AT&T Domain 2.0, which we were talking about just a little while ago, that beginning of virtualization moving its way into the network. Now that was good, but those were the physical network function software moved into a virtualized environment. So you had everything from VMs and the VM tax and everything that you would expect in a traditional IT-like environment, but that creates a lot of inefficiencies. But where we're seeing increasingly is those virtual network functions move to more of a containerized approach. Now these aren't truly cloud native yet, and I know Mehran is going to talk more about that in the Rakuten section, but these are not truly cloud native. And part of that is just where the vendors are in their life cycle, but it's more also is, are the customers ready to accept truly cloud native containerization and microservices? And we're not seeing that quite yet. And when you see that environment start to come, and Rakuten is leading the charge on that, is more and more efficiencies, cost efficiencies, as well as CapEx savings and OpEx savings. So when you look at where we are in this timeline, at least at Dell, many of our customers fall into this space. That virtualization, a little bit of containerization, but not fully cloud native. So this is the journey. We see it with Vodafone has done it on their RAN. Dell has done quite a bit of work with the Dish Networks and others that are doing this journey at the same time. So what we represent, what I represent, is something we call the Open Telecom Ecosystem Lab. It's physically a lab, which is great because every lab is physical. But what we did was make it a globally accessible resource that any customer and any partner in the world can come into. And what we're doing is taking a full set of basically an emulated network, RAN capabilities from all of the top vendors, core capabilities from all of the top vendors, and of course on the OCloud side as well. And what that allows us to do, any customer wants to come in and do certification, validation, or blueprinting, that they can go and do that. It also is about ecosystem. Dell being a platform and really a vendor neutral and agnostic platform means that anyone is allowed in. And I get often asked, well, what about other competitors? And yes, we have competitors in the lab. We have Cisco in the lab. But what's most important is that it's the choice of the customers and choice of the ecosystem to decide what they want to do. And then lastly, many labs, and I know we were just talking about, many other labs are set up for academic purposes or for things like government funding. This is a completely open lab for consumable solutions. So if you're taking a golden configuration, like the blueprint that we built here, that can get deployed in any network. You can take that configuration, we will lifecycle management, we'll wrap it in services, whatever we need to do to ensure that it's consumable. So this is not an experiment, this is not sandboxing, though we do have some really cool AI sandboxing that we'll talk about, but that's what we'd like to do. We have more than 150 partners who've come through this lab in the last 3 years. We've got a few hundred engineers who work around the world. We've got dozens and dozens of different certification programs that involve everything from RAN, Core, OSS, BSS, as well as Edge and ORAN, CRAN increasingly. So everything that's new or old in the network, we have done that use case. We have more than 7,000 different test use cases that we run automatically on our platform. So you can come in remotely or you can come in physically and we can run over and over again. Because the most important part of a disaggregated solution moving towards containerization is this continuous test, continuous optimization, continuous development. And what that means is that the assuredness that you got with the silo, you have to have with a disaggregated network. And that's especially true making sure that the cloud platform is tied tightly to the underlying infrastructure. We have partners come in all the time. As someone who was with many of the small startups over my career, we have a free program that we have self-certified partners come in and they get to access the latest Dell hardware, something that would just not physically be possible or financially possible many years ago. But for larger, more established partners, we had a full dedicated engineering team working with Rakuten to ensure the complete integration from an architectural standpoint and a functional standpoint with the technology. And so we access all of those engineers who have access to our hardware, our software, and every other component for Dell. It's a true blueprint. So where did we get to? We're going to talk a little bit more, but the idea is some of the early findings of the integration is how can we test out, improve, that we had smarter, more autonomous, and automated network management. That was one of the key drivers here, is actually doing call flows and ensuring that the functionality of this infrastructure could work. The containerization of microservices. Can we spin up a Kubernetes environment? Can we sustain it? Because just doing what we call a smoke test, right? Turn the server on, light up the software, that's great. But you're doing duration testing, you're actually doing stress testing, you're doing a regression. And that takes a totally different level of integration and commitment from the partner engineering organization. Because what we have to prove out are what are the benefits, right? Can we reduce the cost? Can we make things more efficient? Disaggregation ultimately seems more expensive because it looks more complicated. But you can extract most of the savings from this, not on the hardware side, but on the operational side. And that's the vendor responsibility of doing a lot of work themselves to validate what it is that they're selling to the customers. And that's the last point, is that you can do one-point validation. But if you're not doing lifecycle management, you're not doing a continuous work when a new code is released, a new server is released, or whatever, or a new GPU or CPU, that work is on a continuous basis and has to happen. And that's truly is vendor responsibility for us to ensure that the market moves to this new containerized environment. So functionally, and we won't go too deep into the weeds. Later, there's a QR code. You can download the white paper if you want to get into the nitty-gritty of it. But functionally, we establish a full leaf spine network, and then we emulated a RAN and a core. The RAN sits on, this is the only product pitch, I swear, XR8000, which is a sled-based design using the latest generation Intel CPUs. You can go see it at the Dell booth, and in our network, hardware guys will go deep on you. But this is a telco optimized, and this is the one point I'll stress, is that Dell made a massive commitment 4 years ago to enter the telecom space. This is the first platform that Dell ever made that was completely bespoke for the telecom network. It's edge, it's hardened, it can be put into environmental cases, it's designed to be out in any RAN installation you could imagine. So obviously it's NEBS compliant and it will continually be updated. It also has a lifespan of 10 years. So this actual server will be in a lot of networks for at least 3 more generations of Intel CPUs. And then of course on the core where you'd expect Dell to thrive, which is more of a data center type based approach. This is our PowerEdge R series. You would see these again in any data center around the world and of course any telco around the world. So I'm going to now turn over some of the Rakuten detail, unless you want us to do this one together. Sure, go ahead. All right, good. So what did the architecture look like? Let's just go a little bit more into, and I'll stop here and start changing slides. Obviously, we talked about the underlying infrastructure. We talked about all of the networking components. most of the RUs and all of this was simulated. When you get access to things like Radisys stacks and Keysight and Viavi gear, we're able to completely emulate a full call flow. So when we talk about, we actually use real UEs. So we've got a bunch of engineers hack some Samsung, some I won't say the brand name, but some Android devices, and we put them into our Faraday cages, either whether the Faraday boxes, the actual Faraday cages, with the radios. We're actually doing it live. So we're actually doing OTA testing in the lab. But then the layers that sat above it, we relied upon our partners to install this and make sure that all of the underlying resources were utilized. You want to go ahead?
Great. So I think a couple of important points to make sure mentioned. We're not didn't do this as an exercise of just qualification. There's an actual deliverable. It's very prescriptive. It talks about the configuration details, how to put in a RAN solution together, how to put a core solution together, the underlying infrastructure and configuration, the best practices for deployment, the benefits that you would get achieved. So what came out of the OTEL certification is more than just, okay, we can run on Dell hardware. It was very solution-oriented. It included cloud as an underlying infrastructure, but it's also very tied to the use cases. So we built a stack for RAN, we built a stack for core, we did zero-touch provisioning automation to make sure we can actually deploy the hardware and the underlying operating system and the use cases on top of that. So it was more of the value I see for OTEL, and I think Dell is very unique in the market that they're doing this, is that if you go into a softwarized network, right, people start to worry, would it going to work? What kind of configurations do I need to have to ensure that it's performant and can function correctly? And OTEL solves that problem because we have picked the right platform for the right use case, tested it end-to-end, and deployed cloud on top of it. The cloud infrastructure is built on top of a baseline operating system. We have two different types of hardware for different use cases, and then deployed cloud and tested the cloud functionality end to end. So what came out of the solution is a very detailed use case and how, including how-to and configuration of how to deploy a potential telco function on top of a cloud infrastructure. So we can maybe talk a little bit. I'm not sure how many here actually have an understanding of our Rakuten Cloud. But Rakuten Cloud is very much a telco-ready cloud. We like to call it the horizontal cloud. It includes a number of key functionalities. It is containerized based. It's based on a baseline upstream Kubernetes. However, we've taken that upstream Kubernetes and enhanced it in 3 distinct fronts. And this is really essential to make sure that it provides the level of capability that would require to run complex telco workload. On the networking side, we add a number of enhancements that actually very much tied to the hardware, including network acceleration card that we support, SRI VDPTK for high-performance networking front haul and back haul. Rakuten Cloud is unique in the sense that it can support both containerized workload and virtualized workload in a common infrastructure. This allows the customer to deploy a telco stack which has a combination of VNFs and CNFs. We also added our ability to add our persistent workload using our cloud-native storage. This is a state-of-the-art software-defined storage platform that is embedded in the cloud, and it is added to underlying Kubernetes and provides stateful services, including snapshot, clone, backup, and recovery, all the kind of things you need to run a stateful workload. There are many applications in the telco world that are stateful and require support for maintaining state, although Kubernetes was born in a stateless environment. Many applications telco operators run on Kubernetes now require state. On top of all that, there's a underlying orchestration layer that can support enhanced provisioning, CPU pinning, for example, for the U workload, a number of enhancements in terms of simplification of how workload can be provisioned, deployed, and managed post-provisioning, including scaling and healing automation, lifecycle management, and all of those capabilities that you need to have a managed cloud. Now, the reason this is essential to do in OTEL is because a lot of the day-to-day operations post the network functions deployment on hardware also has tie into the underlying cloud infrastructure. monitoring of the underlying hardware all the way to the rest of the stack is also embedded in the platform itself. One of the biggest challenges for a large-scale deployment of a network function is overall lifecycle operations, including initial provisioning and also lifecycle management going forward. Our orchestrator, which is also in the platform, I think it's running on a battery, in the platform can provision a bare metal machine in the lab or in the production, zero touch with the underlying hardware infrastructure, configuration of BIOS, configuration of OS, on top of that, installation of Kubernetes and network function. And this end-to-end zero touch allows you to deploy a large number of G-Node nodes on top of the 8,000 servers automatically at scale and quickly. And post-provisioning, all the lifecycle operations and monitoring of the underlying hardware is also automated. You are now able to provide upgrade automation. Let's say you have just realized that certain version of the Dell hardware that has been deployed requires a BIOS upgrade. You create a workflow that does end-to-end provisioning of those upgrades across all the affected devices using the embedded inventory that already exists in the platform. On top of that, the provisioning model, many times you like to do operational changes, configuration changes of network, configuration changes on the hardware. The MOPS management allows you to create a workflow and provision that and scale thousands of these operations automatically. These are one of the reasons we achieved over 30% savings with the orchestrator platform running on top of the network.
That's a really key point. And what we'll talk about, and I do encourage you, read the paper if you're more interested. But the idea of extracting the information that comes in the underlying infrastructure. What is the CPU utilization? What is the power consumption? What is the heat? All of those things are things that we hear that carriers want to understand. What is the impact of a Kubernetes layer on the infrastructure, not just at the BIOS settings or the hardware layer, but what is the actual utilization rates? What do you do when you actually load up a workload like RAN or Core, and how does that affect things over time? We see it with the GPUs in some of these AI applications. It pins a GPU at 100% utilization, right? So that's the sort of characterization of where you're going to get your efficiencies because of the automation and the efficiencies that we created in the cloud layer can already be pushed down into the underlying infrastructure layer to make sure you're using it optimally. And what we saw on all those different aspects, whether it was memory, whether it was latency, some of the jitter, that we far exceeded all the parameters that we established from the outset and resulted in that. Now, the good part is all of that information is captured and gathered into our, what we call solution integration platform, which when we come back in the next test or we do it for our customer, then all of the testing that we did can be run automatically, and we can look at those tests and put them up against what is essentially the baseline or the golden configuration that we did in this blueprint.
After all, efficiency is everything, right? How much you can get out of the deployed hardware is the most important consideration for many purchases. So we made sure that for the key factors, the performance is also tested, and we provided a very comprehensive set of tests that not only the hardware, but the combination of hardware and software shine through.
So again, I'm happy to answer any questions afterward. Really appreciate the opportunity to talk about this here. There's a lot more depth. I'll get my giant head out of the way of the QR code, but do please check it out, and I'll be available afterwards for any questions.
Thank you so much. We again appreciate the support of Dell in its endeavor. I think it's very valuable to the customer. We've seen a lot of interest in the paper and some of the work we've done. The software platform is also available through Dell, so we have a very unique way of going to market together. Thank you very much for your time.